Good afternoon, everyone. Thank you very much for the opportunity to share the knowledge in regards case hardening of gears, utilizing low pressure carburizing and nitriding. We will share the insights, share the technical, let's say, latest development with you, so you may find it interesting in many aspects, economics, technical development, as you may. So before we start, it already has been said that there are certain demands coming from the market in order to develop the products. And definitely we may say that most of the gears require heat treatment, and therefore we would like to speak about this particular technology so that you can see in many aspects of your interest. But in the relation of the demands, we may say that definitely the higher fatigue strength, meaning quicker, more loaded, less in shape, dimensional stability, distortion reduction, process repeatability, sustainability in some aspects, cost effectiveness, higher efficiency and automation. These are all the fields that pushes us, or in which we are trying to push ourselves to be better at some point. And therefore, we would like to share the information, the insights. How does the carburizing, the low pressure carburizing and nitriding responds to those challenges which are ahead of all those which are within the gear industry. So we will start from the nitriding, let's say, perspective, and then after in the second chapter we will go through the low pressure carburizing. So I will call my colleague to keep on going on nitriding aspects.
Good afternoon once again. My name is Jędrzej Malinowski. I'm representing SECO WARWICK as a business development manager responsible for the nitriding and FNC technology. So once again, thank you very much for the opportunity to share the knowledge and exchange the experience with you. So let's go to the point. Generally, you probably know the nitriding very well, but just to remind it, is a thermochemical process based on the diffusion of the nitrogen. We can easily compare it to the gas nitriding, but in this process we are talking about the diffusion of the nitrogen to the surface of the steel, and as a gas who support the nitrogen, we are using ammonia. Ammonia is dissociating inside of the furnace, and the atomic nitrogen is diffused to the steel surface, and the hydrogen is burned out the furnace how to say, outside of the furnace. So as a result of the process, we are achieving the nitriding layer, which can be compounded with these three phases, epsilon, gamma prime, and alpha. You can see the features, what particular phases is responsible for, and based to the requirements, we can compose the layer according to requirements, having in mind these features like corrosion resistant, or of course in case of gears, usually to increase the fatigue resistance for the gears. So how it looks in practice? Usually in traditional nitriding installation, we are talking about the two flow of the gases, constant flow of the gases. We are talking about the ammonia and dissociated ammonia, and we are keeping to have right ratio in the process just to achieve the set point, which is nitriding potential. Proper nitriding potential inside of the furnace. So looking at this diagram, you can see, sorry, the pointer doesn't work, doesn't matter. We can see two lines of these gases, and as I said, we have constant flow of this. The disadvantages of this process is necessity to use constant flow, and also the necessity to use external dissociator, which actually is the small additional furnace, because we have around 900 degree inside to dissociate ammonia outside of the furnace, cool it down, and introduce into the furnace once again. Our technology, we call it ZeroFlow. I will show you why it's ZeroFlow soon, based on the phenomenon of the internal dissociated of the ammonia inside of the furnace. That's why we are using only the ammonia line without any other gases. So gas-tight furnace allow us to use only the as small portion of ammonia as is generally needed. In simple words, we can compare it traditional ammonia for these two British taps. You know it very well, much better than me, I suppose. When we have one extremely hot, which means which means ammonia, and second one extremely cold, which means dissociated ammonia. And for traditional process, we are fix the taps for some position just to get the right cayenne. Cayenne means nitriding potential, and in this example we can tell it like a bath temperature. So we are measuring bath temperature in the drain because all taps are open, so the flow is constantly went through the bath. In our technology, we are using only the hot tap. We create the high temperature, which means high potential in the first stage of the nitriding. It's usual as all technologies on the market using the same way, but for the second stage we are just waiting, close the tap, that's why we call it ZeroFlow, and waiting for the dissociated internally. Based on our technology, we are able to achieve any layer compounds, nitriding layer compounds as we want, same as traditional technology. The difference is that we use much less ammonia to do this. It means lower consumption, it means lower cost, and also lower emission of the post-process gases. How it looks on the trends in the furnace. Yeah? At the beginning, you can see the regular first stage of the nitriding, which went normally, but our technology step in the second step. You can see at the bottom that after achieving the set point potential, we just see the small introduction of the ammonia during the whole process. And this is the key of our technology, is key of all benefits. So probably you are wondering how to do and how to manage fast changes of the nitriding potential, which are sometimes needed, especially according to IMS norms 2759. We see that it consumes a lot of ammonia, it consumes additional portion of the energy, but seems to be needed. Well, the answer on our side from this question is our patented solution, which we call integrated ammonia dissociator. It's internal solution which are placed into the retort and just increase the drop of the cayenne only when it's needed. Usually it is needed only between the first and second step, just for example to remove not necessary white layer, because in some of the application the white layer is not needed or need to be very thin. Additionally, our solutions are equipped in the simulation tool. In the simulation tool we have our 30 common grade steels which are usually used for the nitriding, and thanks to this you have your own guide, your own technologist who can help you how to manage the process. Based on ZeroFlow, we are also able to supply similar technologies, especially like FNC technology, and also post and pro-oxidation, which are used quite often together with nitriding and FNC processes. We can, for the FNC, we can base on the methanol. We can base as a standard solution for CO or CO2. We recommended methanol because it's very cheap solution and give us much better results in terms of porosity of the nitriding layer. It could be compared with CO, but it's much easier to use in the industrial environment comparing to the CO, which could be acid. As a company, we already delivered more than 250 nitriding furnaces. Last 70 is equipped in our ZeroFlow technology, quite new technology on the market, and all we have in our portfolio, as you can see, typical horizontal pit furnaces, but also automated line which could be used for the massive production. And further on I will show you the particular application using automated line dedicated for the gears. In this table you can see the, let's say, standard sizes of the furnaces. Nevertheless, we are open to offer and to supply any kind of needed size of the furnace according to customer requirements. I will shortly went through the some references. You can see some standard horizontal furnace, some standard pit furnaces, and also these dedicated applications, quite huge pit furnaces with a diameter bigger than 2 meters and bigger than 4 meters deep. Same installation dedicated for the big dies, 1.6 meter and 2.8 meter deep. And last not least, this is the application which I would like to present you, is the application which we supplied to Volvo company. This is the application dedicated for the FNC process. We are talking about the 68 type of quite similar gears which are used as a support and as a source of the power for the auxiliary equipments like pumps and so on placed outside of the engine. For this application, we can see that the required white layer was circa 10 microns. The diffusion layer was circa 0.3. We are talking about the 1.2 million gears per year, and that was the first challenge for us, and the second challenge for us was the ammonia consumption and emission of the gases, because the company was placed in the middle of the town, and they used to use traditional pusher solution, and our installation brings the reduce of the consumption 10 times. So they used to use 160 tons of the ammonia per year, and thanks to our application, the consumption was reduced 10 times to 60 tons per year, and whole installation is making around 3,000 cycles of the FNC processes per year. The line was fully automated. The robots are prepared the batches, included also the fixture. That was quite unique because the one operator is able to maintain the whole line. The whole line is equipped with 5 nitriding furnaces, 5 FNC furnaces, 2 preheating furnaces, washing machine, and 2 cooling station. And the heart of the installation is the loader, which are connecting all these parts for the whole cycles. Here you can see short movie. I will skip it just to not interrupt you so long, but the full commissioning was made in our factory. You can see working machine with the gears which were tested after, and so on. Only the washing machine was supplied by another supplier, and it goes direct to the customer. So these tables are simulation of the four-chamber washing machine. But as you can see, it's a regular work of this application. Sorry. So, as a short summary for the furnace, and sorry, one step back for this application, the FNC process was the last process in the production cycle, so there's no need any finishing machining processes after. The after heat treatment, thanks to relatively low temperature of the process, the gears are ready to be mounted into the engines, onto the engines. Key features of our furnaces, you can see that we are able to follow all usual regulations. And as a summary for the technology, because it's most important, our technology offers you the lowest possible consumption of the ammonia and lowest possible emission, which brings you lowest possible cost of the process. And all these things are able to achieve with the same precision of the process and the same proper results as traditional technology. So that would be all on my side. Thank you very much once again for your attention.
Yes, I will rise up a little bit temperature as we are losing a little bit of time. Usually nitriding takes much more time due to the low temperature. Right now we will focus on carburizing, starting on the high C, I would say, and then even increasing the temperature, and you see the benefits of coming from that aspect. So again, as it was said, there's a lot of demands regarding the being better at any point, and the question is actually to be asked, where are you at the current moment? Throughout the whole industry, the typical traditional gas atmosphere carburizing is quite common, but the question is whether is there any alternative. Yes, there is an alternative giving you a lot of benefits, but the question is really whether you want to grab them, use them, and it's whether to keep on going the same way and has been going for years, or maybe shift the gear up and to transition into new technology. So speaking about the alternative for atmosphere gas carburizing, I mean low pressure carburizing. But before we go to the benefits you can get from this LPC technology. Let me call it as a shortcut. Let's summarize what we got used to utilizing the atmosphere carburizing technology in several fields. Relatively long cycles due to the temperature limits coming from the technical nature of the equipment that has to be utilized from the perspective of maintenance and lifetime of that utilization of such equipment. Relatively high energy consumption depending on what source of energy we are using. Atmosphere variability, dependency on the CP potential. Typical carburizing temperatures 920 C or 925, 930 around that level. Presence of IGO due to the nature of carburizing atmosphere consisting of oxygen subelements. Potential hydrogen saturation, decarburization if you wouldn't follow the CP potential in a higher level than the carbon content in the steel. Flammable atmosphere, high emissions of CO, CO2, risk of potential fire and explosion, and reliance on the external equipment like gas generators, atmosphere monitoring systems, oxygen probes, burnout exhaust systems, etc. So this is what we have to deal with, what we got used to it. The question is whether we want to continue. If not, then we should look up on the alternative, since it has been introduced several decades into industry, being most popular in the aerospace field. The low pressure carburizing give you most of all or answer to all those queries we got regarding atmosphere type technology. Let me just list them, and then on following slides I will explain. I will refer to those. Effective and efficient carburizing. Just if you could imagine how precise we could be, if you could imagine fuel injection nozzles, which is on the bottom left-hand corner, where we have to carburize the inner diameter hole of a diameter of 3 millimeters. If you can do it with other technology, I'm okay. If you cannot, definitely low pressure carburizing will be the solution. So if we can do that precisely in the highest quality, there is any issue, or there are some other issues regarding the gears and shafts. However, they seems to be in that perspective quite simple to meet the requirements. Yeah, one of the most beneficial element of low pressure carburizing is no presence of oxygen, which means there is no internal granule oxidations during the whole process, which means that after post machining might be at some point excluded, as we don't have this element, we tend to cause some problems. We have ideal surface quality. I mean, the parts are, after processing, are shiny, silver and shiny, so there are additional post-machining is not required. We can develop the process on the higher temperatures, which means that we can shorten the process. We don't need to condition the furnace prior to the process, so whenever it's needed, we just switch it on, switch it off if it's not. There is no open fire, there is no risk of fire and explosion, so it's relatively safe technology, and it's clean process and environmental friendly. So how does it goes from the more technical perspective? What we use as a carbon carrier gas is acetylene, which will break into carbon and hydrogen once it gets on the parts which are being carburized. The thing is that we start the carburizing once we introduce the gas into the furnace chamber, not at any point earlier, as it is in traditional technology. And we divide the carburizing process into several stages. I mean, pair of stages. Stages of boost, and the diffusion. Boost is when we introduce the gas, and the diffusion is when we want to carbon to diffuse into the case to build up the whole effective case depth. How about the temperatures? Due to the nature of vacuum furnaces, they are purposely designed to be able to handle even 1100 Celsius degrees temperature, so there is no issue in running the processes at elevated temperatures like 950 Celsius degrees, 980, which will bring us a lot of benefits coming from the diffusion law and shortening the process time. What do we control besides of the temperature as natural? We do control pressure, time, and gas flow of the acetylene. But before we do this, there was a lot of discussion regarding the labs, the testing facilities, etc. So having the low pressure carburizing technology, we already are given the lab in it. In the form of process simulator, which we can use for simulation before we run any trials. So before entering the parts into the furnace, we can simulate several, let's say, situation, what kind of effect we would get if we would use these parameters, what we would get if we would change those parameters, etc. So we can play with it before we go on with the real try. So up front, we can optimize our process for fine, let's say, production. Another element is that, you know, tuning the process before trials, we save the cost on real trials. Saving the cost, we're saving the time, so we increase actually our knowledge and increase, let's say, throughput by this means. So the simulator covers all typical case hardening steels. So basically, you don't need to have you know, enormous knowledge in this field. So once you have the furnace equipped with this technology, you are fit with the simulator, and you already are safe in order to run the process. I just mentioned about rising the temperature. One of the benefits of that element is shortening the diffusion time, which means shortening the process. So if you can imagine rising up the temperature from 925, which is typical for atmosphere carburizing, let us consider the 1 millimeter case depth, which would take 5.5 hours. So if we would increase the temperature up to 980, we would decrease the overall time down to 2 hours, 2.5 hours, which means almost 50% decrease, which means that you can either increase the throughput or not require much more furnaces than you would have to if you would run it with atmosphere carburizing at the, let's say, investment point of view, or that so. So if we would go up with the higher temperature, you tend to think that, okay, we would have to give more energy, and that's true because we need to utilize higher temperatures for processing. However, as we overall shortening the overall process time, we are actually saving in this aspect also. So in just short comparison, if you would go up to 950 for this particular case depth of 1 millimeter, you would reduce the energy consumption by about 6% for this particular case. And if you would increase to 980, you would even reach more than 10% savings. Quality, if you just can imagine 4,500 side gears parts densely packed in such a load, and after processing measured on the 40 parts within the whole batch, you got the tolerance of 1400s spread of the case depth. That means the quality is at the very highest level. And what we can also share is that we've got more than 25 years of experience running the LPC installation, carburizing installation, more than 200 installations all over the world. But also we share the knowledge by utilizing our equipment and our R&D. And again, I can confirm that R&D testing labs, it's the right direction for any development of any aspect, as was already said at the beginning in the first session. What about the equipment? There's so many of these. As it was said, depending on where you are, what is your application, what is your approach, we may offer you different solutions. So that means for some of you, single chamber furnaces, high pressure gas quenching, either horizontal or vertical, might be the key point. But for the others, due to other aspects, multi-chamber systems with high pressure gas quenching might be the right solution. However, not in many cases, you can go with the high pressure gas quenching, therefore you have to transition into oil quenching situation, where we got a very pure transition from traditional technology utilizing oil quenching into vacuum carburizing and utilizing oil quenching. One of the latest development of ours is also a pit type furnace, which can be open to air, which is not common, and it's never has been before introduced into a market, which means that you can get all the benefits from the LPC and still utilizing your oil hardening tank, right? So next to your pit type furnace, atmosphere pit type furnace, we can put vacuum pit type furnace, utilizing the same oil tank and getting all the benefits of the LPC technology. What kind of process we do? All typical ones, starting from direct hardening through single hardening and through hardening after isothermal transformation, if you would be interested in grain refinement. Very common, very popular technology right now from the quenching perspective and from the gear perspective and the distortion perspective too is the high pressure gas quenching, which gives you the benefits in lower level of the distortion. However, with the high pressure gas quenching, we have to refer to the most, let's say, powerful quenching mediums like oils. And as you can see, there are several gases which are being used in the market, starting from the nitrogen, the cheapest one, then the helium, the most expensive one, requiring also recycling, and the hydrogen as a potential solution. So the message from this is that it's not that said that you can use high pressure gas quenching for any steels that are on the market, yeah? Even though you wish or you dream to do it in order to decrease the distortion and the cost correlated to that. You might not. However, if you cannot do it, we also have a solution for that. So, starting from the high pressure gas quenching double chamber systems, which can, for the typical case, hardening steels like 20 MnCr5, 16 MnCr5, 18 chrom nickel 7.6, this is a perfect solution, giving you best benefits from the distortion perspective and the quality of the product after heat treatment. In terms of quenching distortion, minimal quenching distortion, reduction of post-hardening machining cost, full control of the quenching process, no washer after quenching, no oils, chemicals, no neutralization costs, no emission pollutions, clean process and environmental friendly. In this particular case, we are considering single chamber furnace of a size 900, 900, 1200, case hardening, a gear of a diameter 800 millimeters and the thickness 200 millimeters with a requirement for core hardness more than 30 HRC. And after processing of that part, we have received core hardness at the level of 35 rock wool hardness, which means that even for such massive parts, we can transit into the high pressure gas quenching technology. If we cannot, we still can transit into oil quench technology. And if the requirements are set a relatively higher than typical ones, as on the picture here, the requirements for core hardness were 340 H Vickers, and for the gears of a diameter 220 millimeters, 170 of a weight 7.5 and 4 kilograms, high pressure gas quenching was not able to meet those requirements. Therefore, the oil quenching was the only solution that could be applied. And of course, due to the different quenching methods, then we will discuss a different level of distortion. However, as you can see, the green points refers to the steel, which is at very high hardenability level, and the point of meeting the core hardness, it doesn't make a change whether you go with oil or high pressure gas quenching. Yeah. in both situations you actually can meet. And then if you would transition high pressure gas quenching, you can get the all benefits by optimizing the gas pressure in order to minimize the distortion. Yeah, as I mentioned, if not high pressure gas quenching, then oil quenching. And also in oil quenching, vacuum oil quenching solution, you can also optimize the distortion, because you can play with the pressure over the oil bath. Due to the design of the furnace, you can play with that. By reducing the pressure, you actually reduce the intensity of oil quenching during the hardening procedure. So this is additional option which you cannot gather from typical atmosphere oil quenching technology. Typical standard sizes, but of course if they cannot fit your portfolio, we may do the customized ones. Different approaches from the design of the equipment, especially from the beginning of increasing the throughput, from the investment point of view. This solution in particular gives you the information that in some cases, instead of one triple chamber furnace can replace two double chamber furnaces. So giving you less investment costs at the very beginning, and providing higher throughput capacity over the year. Of course, high pressure gas quenching as well as the oil quenching, and in this particular case, triple chamber solution giving you production takt time 3.5 hours for 1 millimeter case depth. System integration could be as a greenfield, but of course we can also integrate vacuum equipment into existing atmosphere type equipment. Another aspect, more sustainability, utilizing low pressure carburizing, you don't issue any CO2 at all from the technique point of view. At some point, the system can be delivered fully automated, but if it's not fitting your particular requirement, it could be manually operated line. As I mentioned, semi-automated, fully automated. Nowadays, it becomes more attractive to utilizing automated guided vehicles, so that it becomes more, I would say, trendy, although it's just stepping into the industry. And of course, due to the full automatization, you actually can reduce the labor cost or operator present during the processes, as actually functionality of the system allows you to do that. The recent development of ours, referring the pit type furnaces, more dedicated for large parts, reaching 1.2, 1.8, 2 meters over diameter and a depth of 3 meters. In this particular case, we were carburizing the gears for wind mill systems, and the gross charge 6.5 ton. And the case reaching up to 4 millimeters. So normally if you would do atmosphere carburizing in 925 Celsius degrees, you would take 91 hours. By utilizing vacuum technology and increasing the temperature up to 980, we could have reduced by 50%, which means that you can increase the throughput or drastically lower the production cost in this area, right? Just a few information about this furnace. Actually, it can fit the same solution as you have currently in regards the atmosphere pit type furnaces. Having the temperature uniformity within ±1 Celsius degrees, and the case depth tolerance of 800 within the several testing points within the whole batch of such a huge furnace, which gives you the information that you can drastically lower the energy consumption. In this particular case, for the by reducing by 50%, one furnace can replace 2 atmospheric furnaces and can return on investment within 2 or 3 years. However, all those examples were correlated to batch type heat treatment, but we also have a solution where we, instead of batch type approach, we got single piece approach, giving you much more benefits, especially in consistency in the shape of the parts after heat treatment. due to the different heat gradient through the hardening process at several points of the parts, especially when you treat the whole batch of the parts. Therefore, we come across and have got a solution where we treat each part individually, relying on providing the consistency of each type being treated the same way, giving you the same let's say results in terms of quality and distortion level, and at some point being an alternative to the typical press fixture quenching. So where we are with this solution is that if we come across a single piece element for hardening, we don't need so much high pressure, but utilizing high pressure gas quenching, of course, giving you all the benefits, and you can utilize 10 bar nitrogen quench and be as fast as oil quenching. Yeah, so we don't lose nothing in this terms. And by designing the quenching module dedicated for particular shape of the part, we can optimize the level of distortion as we, in order to optimize the distortion after the heat treatment. This is an example of such a system where one part is coming into the quenching chamber. Prior it was carburized, and then the quenching process starts. So as you can see, in addition to flow of the gas from top and bottom, we rotate the parts in order to make the process even more uniform. And within several seconds, the parts is ready to be proceeded further on. So different kind of solutions, depending on particular application, depending on particular requirements, depending on particular materials, we can provide you the solution optimized for your needs, starting from the high pressure gas quenching, through the oil quenching, batch processing, through single piece processing. Yeah, so there are a lot of benefits coming from this technology. Some of them might be interesting for just part of you. Some of them might be more interesting in other fields. So at least this technology gives you the position to choose what I'm willing to go, where I'm willing to go, what is my next goal, what is my next level of development. So this technology gives you this opportunity to develop yourself, develop your techniques, be on the higher gear, I would say. Thank you very much.
Thank you so much. Requesting Anita to please join me on stage. Yes, requesting you all to please join me in the center. May we have a token of memento for our presenters. Thank you so much for joining us. Yes, so Mr. Marcin Przygoński, thank you so much. And yes, Mr. Jędrzej Malinowski, thank you for joining us. You all can stand ahead of the table and have a picture of the three of you as well. Requesting Mr. Mayur also to join us on stage. And Anita, if you could please felicitate Mr. Mayur as well. It's never the easiest to come on the stage with a lot of technical content. Please, a huge round of applause for them. Coming all the way to India. Thank you so much. Our technical session partner, once again thanking them for all their support. I think the gear manufacturing industry and technicality go hand in hand actually.